All right, so welcome back to another day of Explore More. So today we're going to be exploring more about solving a system of equations using a strategy called substitution. Okay, so in your Algebra 1 class, if your teacher gave you a system of equations like this, 2x minus 3y equals -1, and y equals x minus 1. So there's lots of different ways that we could solve this system. Remember, to solve a system, what we're trying to figure out is what values of x and y make both of these equations true. So in your Algebra 1 class, most likely right now your teacher has told you to graph these two equations and then just click on their intersection. And that intersection is going to tell you the solution. It's going to tell you where the x and the y are the same on both of those lines. Okay, and that's a great strategy. Okay, but today we want to talk about a strategy that we're going to use a lot in Algebra 2 to find the solution without graphing. Okay, and so this first method is called substitution. So in substitution, what we're going to do is we're going to pick one of the two equations, typically the one that looks the simplest, and we're going to substitute some of the values into the other equation. So for this one, the second equation is much simpler. It says y equals x minus 1. So what we're going to do is we're going to substitute into the first equation where it says -3 times y. Instead of y, we're going to substitute x minus 1. Because if you look at this second equation, says that y is the same as x minus 1. And so we're going to take x minus 1 and we're going to substitute it. We're going to put it in the spot where the y was in that first equation. Okay, so let's go ahead and see what that's going to look like. So we still have 2x minus 3, but instead of using y, we're going to substitute x minus 1 into that first equation, and it's still equal to -1. Okay, so why would we want to do that? Well, the problem is we can't, it's hard to solve equations with two variables, right? So by doing this substitution, now we have this equation, which is a little bit more complex looking, but we got rid of the y, so now we only have x's in this equation. So now we can solve this equation. So first step, we're going to distribute the -3. So 2x minus 3x plus 3 equals -1. Combine like terms, 2x minus 3x is -x. We can subtract 3 from both sides, that'd be -4. So -x equals -4, which means that x is equal to 4. So we just found x. We did it. We found the value of x that's going to be in the solution to the system. Okay, so we found x, but now what about the y value? How am I supposed to figure that out? Well, now that we know the x value, we can take that x value and we can just substitute it back into one of my equations. Okay, we're going to use the second equation here. So the second equation says y equals x minus 1. So we'll substitute the 4 in for x. So y equals 4 minus 1. 4 minus 1 is equal to 3. And so now we just found our second value, our y value, that is going to make this statement true. Okay, so our solution to this system of equations would be the point 4, comma 3. So we use substitution to find this solution. Now you could check this by plugging in 4 for x and 3 for y into both of these equations and verifying that what we got was true. Okay, let's look at one more example. Okay, so with this second example, we're going to try to find the solution to this system. So in order to do this, we're going to try to use substitution, but neither one of these equations is super simple as compared to the last example we did. It was pretty clear that y was already solved for. So the first thing we would do, let's go ahead and take a look at the second equation. It's definitely simpler than the first. And we can just solve this second equation for x. We can get x by itself. So we would do that by adding 2y to both sides, and we would end up with 2y plus 11, or 11 plus 2y would be fine also. So first thing we did is we rearranged this second equation. The reason we did that is now we just solved for x. We got x by itself, which means we can now use substitution. We can substitute 2y plus 11 into the first equation. We can substitute that into where the x is. So we solve for x. X is 2y plus 11. So now we're going to substitute that into this second equation. Okay, so let's take a look. What is that going to look like? So this would be negative 7 times 2y plus 11 minus 2y equals negative 13. So we did our substitution. Now we only have one variable here, just y, so we can solve this equation. We're going to distribute the negative 7. So negative 14y minus 77 minus 2y equals negative 13. We can combine like terms. I have negative 14 and negative 2y. So negative 16y minus 77 equals negative 13. Add 77 to both sides to clear that out of the way. Negative 13 plus 77 is 64. And then we would divide by negative 16 and get y equals negative 4. Okay? So we did it. We solved for y. We know that y is equal to negative 4. That's going to be the y value in the solution to the system. Okay? So now what? Now we need to figure out what the x value is. So to do that, we're going to take this y value and plug it all the way back into this original equation. So that would be x minus 2 times negative 4 equals 11. Negative 2 times 4 is positive 8, so x plus 8 equals 11. Subtract 8 from both sides, and we get x equals 3. And so we did it. We found the x and the y value. Together they make the solution to this system of equations. So if we were to graph this, like we've been doing in our Algebra 1 classes, these two lines would intersect at the point 3, negative 4. Or if we plugged in 3 for x and negative 4 for y, it would make both of these equations true at the same time. Alright, so good luck with your problems today. So this is called solving a system of equations with substitution. The next video that you'll watch, we're going to use a different strategy called elimination. Good luck.